Welcome to MaaS v20, On-Call Copilot. A production incident diagnosis engine engineered with zero-token stack trace filtering, GPU context, compression, pgvector institutional memory, and AgentKit human-in-the-loop governance. First, from the terminal, we query the health endpoint up, returning HTTP 200 OK. Next, we query /Paritok/stats to verify real-time GPU proxy connectivity, live token reduction, percentages, and total dollar savings. We can also trigger incident diagnoses directly via curl by attaching a real 123 KB production log. File example development.log to the post-incidents API endpoint. The log normalizer immediately filters 90.1% of third-party gem noise at zero token cost and returns a diagnosis completed response with the HITL inbox URL. Switching to the web console at AgentKit/suggestions. In production, raw exception logs often exceed 100,000 characters. The on-call launchpad accepts raw log pastes or drag-and-drop log files. Here, we click Load Real Log to load a 145 KB production stack trace. Upon ingestion, Log Normalizer runs in pure Ruby RAM at zero token cost, deduplicating repetitive lines and filtering non-application gem stack frames to achieve an immediate 48.9% pre-filter reduction. Below, the Paritok GPU reduction ledger tracks real-time token savings. Scrolling down to the diagnose suggestion card, Incident Agent uses pgvector HNSW similarity search to recall historical team postmortems and compresses the prompt context on Paritok GPU cloud before calling Gemini 2.5. The diagnosis explicitly cites past team precedent and provides a step-by-step technical root cause and code solution. Expanding the collapsible Ruby diff details panel reveals the precise code patch. The review toolbar allows engineers to approve, snooze, or reject with structured feedback codes. Navigating to the factory console at AgentKit/factory, top KPIs highlight system status, total, institutional memories, 30-day HITL decisions, and overall zero-token reduction averages. The live Paritok GPU ledger displays total requests, original versus compressed tokens, percentage reduction, and calculated dollar savings. Below, the 6-step diagnostic pipeline explains each phase, while the HITL quality table breaks down human acceptance rates, decision times, and dominant rejection codes by agent. Navigating to the architecture page at architecture, the hero banner introduces the multi-layer reduction principles. The interactive SVG system diagram maps the primary diagnostic path from ingestion through log normalizer, pgvector recall, Paritok GPU compression, to action cable telemetry and audit persistence. Scrolling through the section, the 6-stage lifecycle details monotonic state checkpoints. The 4-lane topology outlines control, memory, GPU, and visualization layers. The context reduction grid breaks down pre-filter and GPU compression ratios, followed by the complete Postgre SQL16 database schema. Navigating to /RuBrowser, the RuBrowser integration parses Ruby abstract syntax trees to render an interactive D3 class dependency graph, enabling engineers to visually inspect class couplings, inheritance structures, and Sandy Metz code smells for affected domain controllers. Navigating to the runs dashboard at AgentKit/runs, the status cards track running, waiting, completed, and failed execution flows. The active runs table displays versioning, step progress, dollar cost, and execution start. Timestamps for complete diagnostic trace auditability. MaaS v20 On-Call Copilot, turning raw production exceptions into instant, intelligent, team-memorized resolution.